Here we're going to demonstrate a biopsy or cutting method for submitting samples to the lab for DNA extraction and genotyping. So we have our sample collected from the field, which is dried. This happens to be rice. There's an identifier on it. It needs to be recorded in the database. It needs to be recorded in terms of the plate that it is in, so the unique identifier on the plate, and then also the well location. And sometimes you'll also put a barcode on the tube. So in this case, if we're doing the biopsy method, we're going to need a mat, a cutting mat. You can see here, often professional cutting mats are provided with a biopsy tool, or you can use a piece of clear PVC or a solid sort of plastic from a top, from a lid. So in this case, we want to work with our sample away from other tubes so that we don't get contamination. You'll see here that in the plate, I've listed with marker the positions, so the letters and the numbers. You'll notice that there's a corner that is different so that the top will always go on properly, and also the letters and numbers are listed. For DART, both G12 and H12 need to be blank, so I've just put those in here, and we're going to put our sample in A1. So I'm going to label that tube as A1 with a marker so that I know what I'm working with and put it in the correct position when I return it. And then I'm going to take out my leaf samples here, so you can see that these have been collected from the field and they've been dried. And then I'm going to use the biopsy tool to take two 2-millimeter punches out of each leaf. So I'll work with one leaf at a time. You can see they've been biopsied before for demonstration. And I'll take 1, 2 from this leaf, and then this is a push biopsy tool. So if I put it in here and push it, that will then end up putting the sample into the tube. And you can see there that we've got those in the tube, and you tap them down. You can see because of the static electricity, they're hanging up in the tube, but they'll eventually flow down. And then I will then biopsy the next leaf in the sample. And you gotta use it to cut it out, and again, put those discs into the tube. So you'll repeat this until every leaf in your sample has been biopsied and material deposited into the tube. In the case of rice, that is 20 total leaves. Once that is complete, you would do all of the leaves here. You'll want to put the cap on the top, and you'll see that your material will be down in the bottom here. And you can tap it down. At that point in time, you'll return your leaves to your sample packet, and this will be curated. So if these samples get lost in transit or there's a problem with genotyping, you'll always be able to go and resample them. Or if you wanted to use them for a different purpose, you could always go back and get material out. So after that has been completed, you need to clean the tool in between sampling varieties so that you don't get contamination. So we'll use 70% isopropyl alcohol. This is a little wash bottle here, and you will need to wash and dry the tool. So doing it, you'll need to push this out, swirl it around, and then you'll want to dry it off with a disposable paper towel. Again, extending it, cleaning it, washing it again, making sure that it's thoroughly clean. And then the same thing for the wash water basin. If you've been using that, you want to clean that out so that the next sample isn't contaminated. And similarly with your cutting mat, you'll want to clean that off thoroughly before the next sample. You will need to wait for things to dry. So because of that, you may wish to have more than one biopsy tool so that it can be drying while you work on the next sample. Now, the other way to do this is the same procedure, except using scissors to cut small amounts rather than a biopsy tool. The advantage of this is that biopsy tools can be more difficult to come by than scissors. The disadvantage is it's a little bit harder to do in terms of handling. So in terms of cutting with a pair of scissors, I like to use a piece of parchment paper, and here you'll just be taking the smallest amount of leaf, and you want a similar amount of leaf for each one. And you can see here that it can be a little bit difficult as you cut, that material can end up being scattered. So you want an adequate amount of parchment paper to capture that sample, and you'll just snip off tiny amounts of leaf from each leaf in the sample. So this will be about a couple of millimeter piece. And that will then go into a tube. So in terms of getting it into a tube, there are a couple of ways. Again, we want our tube to be worked with away from the other tubes so that we don't get contamination. In this case, the sample will be going into A2. So I would write A2 as to the location. And you can either use tweezers to pick up the individual pieces and put them into the tube, or you can also make a funnel with your parchment paper to put it into the tube. I prefer doing the funnel because I feel it is faster than the tweezers, but because of static and other considerations, this can also be more difficult to do properly. And again, tapping down the sample, putting it in its location, and sealing it. In order to prevent contamination, parchment paper needs to be thrown out between each sample. And again, washing in 70% isopropyl alcohol, all of the implements you use. So if you use tweezers, those get washed off. Your scissors, of course, are also needing to be washed in between samples and dried. So here with the disposable paper towels, you'll want to throw those out afterwards. And again, washing out your wash basin that you've used as well, if you've used anything that's being dipped into, to make sure that no contamination can come from there as well. Again, returning the sample to the bag. Here again, I didn't do all of the leaves for demonstration purposes, but you would take the same amount of material from each leaf, either by cutting with scissors or with a biopsy implement. Again, this biopsy implement has this sort of automatic extractor, but you can buy other ones that just have a hole that you then have to push out the material using a long wire. Either will work, but this one is a little bit easier. You can see that sometimes this implement gets jammed. When it does, you need to just pop it back in by touching it down. You will fill up your plate, then put on the top, and you will use either saran wrap or painter's tape to secure the top, and then this will get packed up and shipped to the lab, where they will do the DNA extraction and then the genotyping of the samples.